Hello everyone, it's me Abhishek Thapa. Today I'm back with another new video. I'm glad to share you that I have successfully accomplished the second task named as stock market prediction and forecasting using stacked LSTM as an internship on Let's Grow More IT company. The datasets I have used for the accomplishment of my task is from this URL. You can check it out. This project mainly focuses on the techniques and the tools for handling the time series datasets. What is time series datasets? Before that, firstly, let's understand the time series data. Time series data is the data that is recorded over consistent interval of time, and the time series data sets consist of more than one attributes depending on the date time attribute of our data sets. I have used I have used the stacked LSTM as a machine learning uh, algorithm for the stock market prediction and forecasting. What is LSTM? LSTM stands for the long short-term memory, that is an artificial neural network used in the fields of artificial intelligence and deep learning. For solving the time series analysis and time series problems, we can go through the two approaches. First is univariate time series analysis. Univariate time series model means that there are only one dependent variable on the time series model. That is only one attribute, only that is each variable on the data sets depends only on its past values, but does not depends on the other variables. But and another approach is multivariate time series analysis. It consists of more than one time dependent variable, and each variable depends not only on its past values but also has some dependency on the other variables. You can get the understanding of the univariate time series analysis and the multivariate time series analysis after going through this video also. It is just a theoretical concept. Now we have the following. I have used the following 10 steps to accomplish my project. Let's dive into the project. First, I have imported the pandas, matplotlib, numpy, and I have loaded the data sets using the above URL mentioned URL and read underscore CSV method of the pandas. I have checked the shape, and we have the 2035 number of rows, 2035 number of rows, and the 8 number of columns. All the data sets, all the attributes of our data sets are in numeric form except the date attributes. We check out for index. We also analyze the statistical properties of our data sets. Also checked for the any missing values, and I have plotted the close attribute of our data sets into the histogram. You can see that. Now, the main concept comes here. When we deal or work with the time series data, we have to increase the time in the date component as much as possible. We can do that by telling the pandas which our column has the dates in it using the past dates parameter. So we can do this by importing the data again, but this time with the past dates as a parameter. Look, before uh, this step, we have also imported we have also loaded our data sets, but there is no use of any past dates parameter in the read underscore csv methods. But for giving the more emphasis to the dates attributes of our data sets, we have used the past dates as a parameter and passed the dates attributes in to that parameter. So after doing that, let's see the data type of the date attribute in both the data frame. In df, which uses the past dates attribute parameters, in that data frame, the date attribute is of the type emmet, which is equivalent to the Python datetime data type. So, and in the Tata global data frame, we can see that the date attributes is of the object data type. So converting it into the equivalent Python datetime data type, we can implement various methods and attributes of the datetime data type of the Python for analyzing our data sets. Now in step number 2, I have gone through the data cleaning and ordering or sorting the data sets by date from the oldest to the newest data. Firstly, I have checked for any missing values in our data frame df. There is no any missing values, you can see that. Also, now we have sorted the data frame by date. While working with the time series data, it's a good idea to sort it by date. Look, for that I have first visualized the data sets. There was from the beginning it was from the 2018 and it's gone to the 2010. It's in the descending order, that is from the newest or the latest data to the oldest, but we need to arrange our data from oldest to the newest. For that I have sorted the our data by date in the ascending order, you can see that. And our first our data is will be arranged in from the 2010 to 2018. Now let's visualize the closing price versus date. I have plotted the scatter plot with the x label as a date attribute and the y parameter is the closing price of the stock. Now the another important concept that it is better to save our original database and make it unchanged. For changing, let's make its copy. So, while dealing with data analysis, we can all we it is always a better idea to save our original data sets and making it unchanged. But if there is any requirement of changes, then we can make those changes in our duplicate data sets, so that our original data set will be always available in the exact form. Now in this way I have make our data sets with the index starting from the 0 1 2 3. I have ordered in this way, you can check it out. Also I have plotted the correlation matrix, and from this correlation you can see that nearly almost all the attributes have high correlationship with each other. So we can use univariate analysis for this purpose. Also this is one of the one of the reason why I am implementing this problem using univariate analysis. I have also plotted the variation of the closing price with the different date year. You can see that from 2011 to 2019, the value the closing price values goes on increasing. But after 2018, it is now declining uh, till 2019. Now, applying the step number 3, applying the univariate approach by selecting the closing price as the target variables. Univariate analysis of closing price. For this task, I am just doing the univariate analysis of closing price using the stacked LSTM and just taking the close attribute from our data sets. You can see that I have used the close underscore df and the copy underscore from the copy underscore df data frame. I have used the only the close attributes. So this is the univariate analysis because I have only used the closing price attribute of our data sets in order to predict the closing price of our closing price, or in order to forecast the value of the closing price in future. So this is the univariate analysis approach. Now let's explore and analyze our data sets. Now close df dot size is to 2035. Now also I have plotted the same graph previously I have plotted. You can see that with the increase in the year data set, the closing price or the value goes on increasing, but after reaching the 2018 to 2019 it is now declining. Now in step number 5 of our task is pre-processing by min-max scalar. Why min-max scalar? Because it scales our values in the range of 0 to 1, that is the small range. And the reason behind that is that the LSTM is very sensitive to the small change in the value, and so to scale to the of the data. So for that we use the min-max scalar, as it is scale in the range of 0 to 1. For that I have used the I have imported the min-max scalar from the sklearn.preprocessing, and I have fitted our dataset with the by reshaping it into the what raw matrix form, and I get that our datasets as follow. Now for this video I'm just explaining up to the step number 5, because my video is getting too much long. So for the remaining steps from the 6 to the 10, please you can check out the next part in the video that I will be mentioned in the description below, or you can go to the playlist as well. So thanks for watching the video.